February 2013. A rock the size of a 6-story building falls out of the morning sun over Russia, and no telescope saw it coming. It explodes 18 miles up with the force of 30 Hiroshima bombs. 1,500 people are hurt. The question isn't if it happens again. Every day, Earth sweeps through a shooting gallery. Most rocks are dust, but somewhere out there is one with our name quietly written on it. For 4 billion years, every species that met one had a single option: die. We are the first that might get a say. So how do you stop a mountain moving faster than a bullet? The answer every action movie reaches for is simple: blow it up. But real scientists spent decades on a gentler idea. Don't destroy the asteroid, just nudge it, years ahead, so it drifts past a harmless miss. In 2022, NASA tried it. A spacecraft the size of a fridge flew 10 months to a moonlet called Dimorphos, aiming to ram it. It hit at 14,000 miles an hour and vanished in a flash. Then telescopes watched to see if a tiny rock had truly shifted. It had. Its orbit shrank by 32 minutes, far more than the little probe alone should manage. Where did the extra push come from? The secret was the spray. The impact blasted a plume of rubble into space, and that recoil shoved the asteroid harder than the probe did. So a nudge is real, but only with years, even decades of warning. Long enough for a gentle push to grow into a clean miss. Chelyabinsk gave us 0 warning. Dart barely moved a rock the size of a stadium. Against a real monster, a bicycle can't shove a truck. So here's the problem that keeps planetary defenders awake. What do you do when the rock is too big, too close, or spotted too late? Here's the strange part. One team's answer isn't to move the asteroid at all. It's to shatter it, like a hammer through glass. The tool is almost comically simple: a metal rod, not steel, tungsten. The same dense, stubborn metal armies fire to punch through tank armor. Tungsten is well over twice as heavy as steel, almost as dense as gold, and melts hotter than any other metal. It does not flinch. Fire a normal projectile at a mountain, and it splatters like a snowball. A tungsten rod behaves like a nail instead. It drives inward. It drills deep before unleashing its energy, so the blow lands inside the rock. A punch to the gut, not a slap on the cheek. Now stop imagining one rod. Imagine 100, packed in a grid like a bundle of metal straws, riding a single rocket toward the rock. The team calls it, plainly, Pulverize It. The rods fan into a wall and strike together at 12 miles a second, faster than any rifle. Each rod bores its own tunnel and detonates its speed deep inside. Not one wound, but 100, tearing through the asteroid from within. The rock doesn't get pushed, it comes apart, a cannonball turning, in an instant, into a spreading cloud of gravel and sand and dust. And here is the beautiful trick. A cloud can't crater a city. Spread that same mass thin enough, and Earth's own air becomes a shield. 60 miles of air is the best armor we have. A single boulder punches through it. A swarm of pebbles burns up trying. Every fragment small enough, under about 50 feet, flares into a harmless shooting star, its energy spent as light and heat high above us. The boulder that could flatten a city becomes, instead, the best meteor shower in human history. Terrifying to watch, but harmless to the people underneath. That's the whole philosophy in a single line. Don't fight the mountain. Turn it into weather and let the sky finish the job. But does the math actually hold up? Simulations say yes, and the numbers are startling. Take a 50-meter asteroid, a Tunguska, a whole forest flattener. One tungsten volley breaks it into roughly 1,500-meter-wide pieces, small enough that nearly all of them never reach the ground. And the pieces don't stay clustered. In the hours before impact, They drift apart into a cloud stretching 60, 90, even hundreds of miles wide. So they don't arrive as one crushing blow. They arrive scattered across the sky and across time. 1,000 flashes instead of a single hammer. The energy that would strike one spot as a bomb is smeared across a whole region as a light show. Same energy, opposite outcome. Which sets up the twist that flips this whole field on its head. Why a plan that sounds reckless might be the safest we have. For decades, one fear ruled asteroid defense. Never break the rock. Turn one bullet into buckshot, the thinking went, and you multiply the danger. But that fear quietly assumes the pieces stay big and stay together. Shatter it finely enough, early enough, and the assumption simply falls apart. Here's the flip. With deflection, catching the rock late is a death sentence. With pulverizing, catching it late barely matters. Sometimes it even helps. The later you fire, the less the debris spreads, but you need far less warning than deflection could ever survive. Timing stops being the enemy. That's the reframe. Deflection is a chess game you must start years early. Pulverizing is a reflex, something you could do in the final hours. And they mean hours, literally. Their tables run terrifyingly short. 10 days for an Apophis-sized giant, a single day for a 100-meter rock. And for a Chelyabinsk-class surprise, around 100 seconds. Less than 2 minutes between a launch and turning a city killer into a sunrise of sparks. The most surprising part? We may already own the hardware. No exotic new engine, no 50-year program, just rockets already sitting on launch pads today. A single Falcon Heavy or Starship, the team argues, carries enough tungsten to take on a monster the size of Apophis, a 1,000-foot mountain. For the truly enormous, the civilization enders, you go nuclear. Drill the tungsten in first, then tuck a warhead into the hole it leaves behind. The physicist behind it, Philip Lubin, puts it bluntly. We possess the technology to build this now. Not someday. Now, with what we already have. So why isn't it built? Because breaking a planet killer is a gamble, and not everyone likes the odds. Critics see real danger in that debris. Get the fragments too big, and instead of one impact, you see dozens of airbursts, each a blinding flash, a shockwave, shattered windows below. It has never been tested at full scale. It remains a proposal, not a shield. The hardest questions are still waiting for an honest answer. But step back and see what even the argument means. For the first time, extinction by asteroid has become a problem with a to-do list. The dinosaurs never saw it coming, and never could. No telescopes, no rockets, no options. Only the sky, and whatever it chose to drop. We are the first creatures on this planet that can look up, see the rock coming, and ask, so what do we do about it? Maybe the answer is a gentle nudge, years in advance. Maybe it's a wall of tungsten and a sky full of sparks. Probably it's both. What matters is that the sentence has changed. It used to end in nothing. Now it ends in options, in engineering, in a fighting chance. Somewhere out there, a rock may already be drifting slowly toward us. This time, we'd see it. This time, we might just answer back. And it might just look, from the ground, like the most beautiful meteor shower anyone has ever survived. A warning, answered, in light. Thanks for watching. If you enjoyed this, subscribe. There's more where this came from.